Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the October-November 2023 pure mathematics paper from Cambridge. This is a 9709 syllabus, paper 1, variant 2. This question here is starts off about this quadratic equation, the equation of a curve y equals x squared minus 8x plus 5, and we're asked to find the coordinates of the minimum point of the curve. Now, the minimum point of the curve, if we have a quadratic, can be found in two ways. One way would be by completing the square, and the other way could be done by differentiation. I'm going to show you both ways. I'm thinking in this case, completing the square would be the easier option and would be suitable for the rest of the question, which is dealing with, transformations. But either way, doesn't matter how you find it. So I'll show you both ways. So let's start with completing the square. Okay, so you start off with y equals x squared minus 8x plus 5. Now, when we complete the square, we express this in such a way that you have a square bracket. And the x term is only mentioned once. So what you do is you rewrite this in a way. So you put x squared. Okay, there's going to be an x here. The number multiplying the x squared must be a perfect square number, and 1 is a perfect square number. That's fine. So this is x squared. So this x squared becomes x. Then whatever sign comes between the x squared and the x term, you write that sign down, and then you take the coefficient of the x and you take a half of that coefficient and just write the coefficient down inside the bracket. Now this, if you expand it, would give you x squared minus 8x, but then it would give you plus 16. Okay, if you expand x minus 4 squared, you square the first term, you multiply them together and double it, negative 8x. But it doesn't stop there. You're going to have to square the last term, give you plus 16. Now, we don't want the plus 16. We want to get this for now. We want what we have here to be the same as that. So how do we make it become the same as that? Well, we have to just take away that 16 that's extra. Now this is the same as this. They're exactly the same. X minus 4 all squared minus 16 is the same as x squared minus 8x. Because you're taking away 16 from this. Okay, it becomes x squared minus 8x. So this is x squared minus 8x. Okay, so now what I've highlighted is the same, but I have got a plus 5 at the end, which I've got to include. Now we can say that y equals x minus 4 squared minus 16 plus 5 is minus 11. So this is the answer, not the answer. This is the form from which we can write down the minimum point. Okay, so we've got it in the right form, and now we can write down the coordinates of the minimum point. Now, as this is a quadratic, it's going to have this type of smiley face, opening upwards kind of shape, have a minimum point, okay? And that minimum point is going to be the place, okay, where for the x coordinate, it's the x coordinate of the point, okay, will be the number that you have to put inside this bracket that makes the bracket 0, which is 4, because 4 minus 4 is 0, and whatever's left outside the bracket is the y coordinate of the vertex. So the minimum point is 4 and minus 11. 4x and minus 11y. Why is it the minimum point? Okay, some people will ask, why does this form give us a minimum point? It's because if you think about this, it's easy to analyze this algebraically. You have y equals minus 11 plus x minus 4 squared. I've rewritten it this way just to make it clear, why arithmetically we're going to get the lowest point. And you can think about it as we've got minus 11 and we're adding something to minus 11. Okay, and what we're adding to minus 11 can only be positive, because we know that x minus 4 squared must be greater than or equal to 0 for all values of x, because you're squaring it. So you're always going to be adding something to negative 11. So, it's always going to be, the curve is always going to be above minus 11. The lowest you can ever get is when you add nothing to negative 11. And that's when x equals 4. When x equals 4, you're going to have minus 11 plus 0. It will be 0 squared. So that's why when x equals 4, you get the minimum point, because that's the value of x that makes this bracket 0, which makes you add nothing to the negative 11. And negative 11 is the lowest point that you can get when x equals 4. Right, so that's the reason why that's the minimum point. Okay, so I hope that was clear for that. Now, as I mentioned, there's also an alternative way to find the minimum point by differentiation. So we can say an alternative method. We can use differentiation. So we start off with y equals x squared minus 8x plus 5 minus 8x plus 5. Now, we're going to differentiate this, okay? And the reason why differentiating helps, first of all, we multiply by the power, and we take 1 from the power, so it's 2x to the power of 1, and the x term, you drop the x, and the constant term becomes 0. Is because we know at the place where it turns, which I've drawn up here, the gradient of the curve is equal to 0. If you drew a tangent at that point where it turns, the gradient at that point would be 0. Okay, so at that point here, at this point here, you can say dy dx equals 0. And dy dx, as we mentioned, is a gradient function. So at the minimum point, and we know it only has a minimum because it's a quadratic, has that shape, we can say dy dx must equal 0. So we can say 2x minus 8 equals 0. 2x equals 8, so x equals 4. That's the x coordinate of the turning point. To find the y coordinate, we put it back into here. So then y equals 4 squared minus 8 times 4 plus 5. That's 16 minus 32. That's negative 16 plus 5, negative 11. So that's why 4, negative 11 is the coordinates of the vertex, of the minimum point. Okay, so there's two alternative ways to find the coordinates of the minimum point of the curve. I personally would prefer to use the completing the square method, but both of them are perfectly fine. Now, it says the curve is stretched by a factor of 2 parallel to the y-axis and then translated by the vector 4, 1. Find the coordinates of the minimum point of the transformed curve. So this point, which is 4, negative 11, this is the minimum point, is transformed by two things. So first of all, the first transformation is going to be a stretch, vertical stretch, okay, of scale factor 2. Now, vertical stretch, any transformation that causes a vertical change will only affect the y-axis. So the x-axis will be the same, the x-coordinate will be the same. The y-axis, you're going to take the negative 11 and you're going to multiply it by 2. This is going to be multiplied by 2. Okay, so you end up with negative 22. Okay, so that's going to be after the first transformation. Okay, we just do it like that. The first step is, it says, first of all, it is stretched by a factor of 2 and parallel to the y-axis. So that's vertically, okay, upwards, and translated by 4, 1. So first of all, that's the vertical stretch. Only affects the y-axis. The x-axis is unchanged. The x-coordinates are unchanged. The y-coordinates are multiplied by 2 for a vertical stretch. Secondly, you translate it by the vector 4, 1. Okay? So let's take the point that we got to now, which is 4, negative 22. Okay, let's do it. This is now translation by 4, 1. So let's do this over there. So that we got. Okay, so this is the first stage. This is what happens first, and this is what happens next. So translation by 4, 1. Now, the top number is what happens to the x coordinate. And the bottom number is what happens to the y coordinate. Because in vectors, the top number is horizontal. So basically, we have got to add 4 to the x coordinate, and we got to add 1 to the y coordinate. Okay, that's basically telling us it moves 4 spaces to the right, and 1 space is up. So the x coordinate is going to become 8, and the y coordinate is going to become minus 21. So you end up with the new minimum point 8 and negative 21. That's the minimum point of the transformed curve. 8, negative 21. There's the answer to part B. Okay, the answer to part B. Okay, and now for part C. Find the equation of the transformed curve, giving the answer in the form y equals ax squared plus bx plus c, where a, b, and c are integers to be found. Now this is what's happened to the curve. The original curve was y equals x squared minus 8x plus 5. We wrote it as y equals x minus 4 squared minus 11. Okay, and we worked out the vertex was 4 and minus 11, the minimum point. Okay, so let's see how we can now apply the transformations in this order onto what we have here. Okay, so first of all, I'm going to show you both ways using this form and using that form. Supposing we had not completed the square, we can do it in both ways. I'll show you how we end up with the same answer at the end. Either way we do it. So first of all, we're dealing with a stretch because they told us to do it in this order. They told us to do it in this order, so we must do it in the order they told us. So to a stretch of factor 2, so it's a vertical stretch, okay, scale factor equals 2. So what I'm going to do is I'm going to take the equation in this form. I'm going to multiply by 2 the whole thing. So I have x squared minus 8x plus 5. That's the first step. Okay. If I take it in this form, I'll do the same thing. Let me just draw a line down to separate my work. Okay. If I use this other method, if I have it in this form, then I'm going to do the same thing. I'm going to multiply the whole thing by 2. So 2 times all of this, x minus 4 squared minus 11. So I'm multiplying the whole thing by 2. That's the first thing. Let me just move this a bit this way, give myself some more space. All right. Now, the second step is the translation by the vector. It was 4, 1. Okay, 4, 1. So this means basically two things. First of all, the x coordinate is going to be moved 4 to the right, which means when you do that, that's like fx. If you move to the right, you put minus 4. You replace the x with x minus 4. So anywhere I see x, I'm going to replace it with x minus 4. So it's be x minus 4 squared minus 8 times x minus 4 plus 5. Okay. And then I'm going to add 1 to the whole function. Let me just make some more space here. I'm trying to do everything at one time to show you. So then I'm going to add 1 to the whole function. Okay. The plus 1 means add 1 to the whole thing. So you have this 4 units to the right means replace the x with x minus 4 because you do the opposite. Right? You do the opposite. So x minus 4 inside the function means 4 to the right. And then plus 1 to the whole function. So this should give us the correct answer for how the the equation of the transformed curve looks. So should this. If I do the same thing here, I'm going to replace the x with x minus 4. Okay, so I'll have 2 times. Now this x is going to be replaced by x minus 4, so I'll have x minus 4, and I've got another minus 4 there. I have to write minus 4 again. Squared minus 11, close the bracket. Then I add 1 to the whole function. Same thing. Okay, so now let's expand and simplify this and see what we get. And it should be exactly the same as we get there. So you can do it either way. There's 2 alternative ways we can do it. So this is y equals 2 times. This is going to be x squared minus 8x plus 16 minus 8x plus 32. Okay, plus 5, and then outside the bracket plus 1. So you have y equals 2 times. This is going to be x squared. You got minus 8x, that's a minus 16x. You got 16 plus 32, that's plus 48. And you're going to have plus 5. 48 plus 5 is 53. Okay, that'll be plus 53. and you got plus 1 on the outside. So you end up with y equals 2x squared minus 32x plus 107. Okay, 2x squared minus 32x plus 106, then plus 1 on the outside, that's plus 107. So there is the equation of our curve after the transformation. Hopefully this will give us the same thing as that. Let's see what happens. You have y equals 2 times, that's going to be x minus 8 in brackets squared minus 11, and then plus 1 on the outside. So y is equal to 2 times, you're going to have x squared minus 16x plus 64 minus 11 and 1 on the outside. So y equals 2 times, that's going to be x squared minus 16x. 64 minus 11 is going to be plus 53. Looks like it's working out to be exactly the same. So you have y equals 2x squared minus 32x plus 106 plus 107. So you see we get exactly the same answer. And from the form over here, we see we're going to have, if I take this, this will be y equals 2 times 8x minus 8 squared minus 22 plus 1. So the vertex for this will be 8, and it's going to be 22 minus 22 plus 1 minus 21. And that's exactly what we found the vertex of the transform curve was. So if I take this form here and write it in the way that when we complete the square, you'll have y equals 2 times x minus 8 squared minus 22 plus 1 minus 21. That's exactly what we found when we did this. So we can see we're on the right tracks there. So I personally would have used this way. I would have used this way using completing the square, but both ways are perfectly fine, as you could see. You basically, for the vertical stretch, you multiply the whole thing by 2. Okay, and for the translation, for the x part, you replace the x with, it's like the opposite. So if it says 4, you replace it with x minus 4. If it was minus 4, you replace it with x plus 4. And for the y part, you just add 1 to the whole thing. So added 1 to the whole thing at the end. And then you get your answer. So those are, a couple of ways of doing or tackling this question. I hope that was clear. Give the answer in the form. Yeah, that's fine. We got the answer. And other questions from this particular paper can be found in the playlist that will appear in this section over here. Other questions from the topic of quadratics. I'll put the playlist here for quadratics and the playlist here for transformations of functions from Cambridge. And also I'll put here transformations of functions from Edexcel as well. Thank you for watching and see you soon.